Welcome to the lab's resource video. We will refer to this video for some parts of the lab. In addition, please have the worksheet open. DGFN Lab Resource Overview. As you have seen, logic is extensively used within electronics and programming today. Both the RPI and Arduino offer a very flexible and cost-effective way of creating logic circuits. Details of Part 1. A. Introduction to Thonny, the latest Python editor for the Pi. B. We will create and test a hello message using Thonny. Note: Python Thonny is not the only programming language you can use on the Pi. Before we begin programming, note this image details the pinout of the EAT module attached to the Pi. We will use this later. Open Thonny from here. This is the Thonny IDE. From here we can create and test our programs. We create our Python scripts, the name given to Python programs, in this area. Here we can see the output from the Python scripts, or any error codes, etc. Before we start coding, let's make sure your IDE is set up like this one. Click the Tools menu. Select Options. Ensure all these are checked. Your IDE should show these line numbers, very useful. I will now enter a simple little program that will get the Pi to send out a hello message. Review the entire video, pause where you are told, then enter your version. A sign-off is required. My first line is a comment line. The number makes it a comment in Python. It's to help the reader know what the script is supposed to do. All code you create should have comments. As you can see, we will save our file to the desktop on the Pi. Yep, here it is. Now let's click here to run our script. Oops, there seems to be some problem. It doesn't like this. Perfect. Simply click here to stop testing the script. Note: with Thonny, upon successful compilation, an automatic process is started when we run. The script file is automatically saved. Pause the video. Now it's your turn to program the hello message. Your message should also include your name. When you have shown the prof your working version, get a sign off, then continue to watch the video. I will now close the file and then clear the shell view. So we can start programming the next part. Part 2 Overview. With this script, we will use a library file, built into Python 3.x, this will provide a short delay, just as you did with the Arduino. We will also get a variable, this is just a fancy name for a memory location, x, to increment by 1. The variable's value is printed out every 1 second. Click here to open a new file. Again, I will enter the code and comments, then test the script. Review the video until you're asked to pause, where you will then create/test your version of the script. Pause this video now and enter the code as shown, with the comments. When complete, continue to play the video. Oops, forgot this, it ensures our count will always start from 0. If we press this, we can create an interrupt and cause the while loop to halt, stopping the script. Your task is to copy and then modify the script as follows. Your version is to start counting from 5, it must also print your name as well as the incrementing value of x, the delay must be changed to 1/2 second, finally ensure you include a comment line that has your name in it. Again, show your prof the working version of your script, another sign-off is required. That concludes part 2, now shut down the Pi correctly, as you are going to wire up some devices to the EAT module, that will be used in the next part. Please ask if you don't remember how to shut down the Pi safely. Now recreate this circuit, only when you're finished wiring up, should you reconnect power to the Pi. Connection. Schematic. Circuit diagram. Now pause the video, press play when you have built the circuit and powered up the Pi again. Open Thonny and enter the code and comments. When you have successfully created this script, you should see these messages and the LED on the breadboard should be toggling on/off. Here is an example of my code running. Note this video was created using the same Pi. Now refer to the lab worksheet to complete the remainder of this lab. You will need to power down the Pi again, safely. Hope you enjoyed the video. Copyright 2017 Philip Jarvis and Durham College.